LibreText Introductory Chemistry, Section 1.5, A Beginning Chemist, How to Succeed. Examples of the practical applications of chemistry are everywhere. See Figure 1.5.1, which says, Chemistry in everyday life. Although most people do not recognize it, chemistry and chemical compounds are crucial ingredients in almost everything we eat, wear, and use. The photograph that has been augmented is on page 1.5.1. A woman sits at her computer screen with a notepad in front of her, looking at a lattice, a molecular lattice, and there are objects on the table. One is an iPad, or apologize, it's an iPod Touch, or an iPod. I don't remember which model. There are glass containers, one of water, one of apparently potato chips. There is a ceramic cup full of what apparently looks like tea. There is a fruit called an orange. There is a pencil she is holding, and they show, and so there's a pencil she's holding. And from each of these, the orange, the pencil, the iPod, the glass of water, the potato chips, and the tea are bubbles popping up, showing what's contained within them. The orange, vitamin C, the pencil, graphite, the iPod, lithium, or lithium carbon oxidate, I believe, LiCoO2. Maybe not carbon. I'm not familiar with CO. Please look it up. Li, lithium, CoO2. The water, H2O. The potato chips, sodium chloride for the salt, and the glass of, or the cup of tea, caffeine. When you read these in class, whether or not you have sight, it is important to describe what's in the photo or in the graphic, because not everyone reads a graphic in the same way. And on the concept of gender, I use what a person is presenting as the most common gender stereotypes: hair color, form of face, the way a pencil is held, jewelry, uh, mannerisms, and how she is looking, the commonality of wanting to present women over men in these science texts to expand STEM. So, without regard to the gender of the person, when a person presents themselves a particular way, they tend to want you to identify them as that gender. If this individual, earrings that she's wearing, if this person happens to be male, uh, I don't think he should or would mind being called she. Examples of the practical applications of chemistry are everywhere. Figure 1.5.1. Engineers need to understand the chemical properties of the substances needed to design biologically compatible implements, or engineers need to understand the chemical properties of substances needed to design biologically compatible implants for joint replacements, or to design roads, bridges, buildings, and nuclear reactors that do not collapse because of weakened structural materials such as steel and cement. Archaeology and paleontology rely on chemical techniques to date bones and artifacts and identify their origins. Although law is not normally considered a field related to chemistry, forensic scientists use chemical methods to analyze blood, fibers, and other evidence as they investigate crimes. Crimes. In particular, DNA matching, comparing biological samples of genetic material to see whether they could have come from the same person, has been used to solve many high profile criminal cases since about 1981, as well as clear innocent people who have been wrongly accused or convicted, sometimes many years later. Forensics is a rapidly growing area of applied chemistry. Forensics is a rapidly growing area of applied chemistry. In addition, the proliferation of chemical and biochemical innovations in industry is producing rapid growth in the area of patent law. Ultimately, the dispersal of information in all the fields in which chemistry plays a part requires experts who are able to explain complex chemical issues to the public through television, print journalism, the internet, and popular books. Hopefully, at this point, you are fully convinced of how important and useful the study of chemistry can be. You may, however, still be wondering exactly what it is that a chemist does. Chemistry is the study of matter and the changes that matter undergoes. In general, chemists are interested in both characteristics that you can test and observe, like a chemical smell or color, and characteristics that are far too small to see, like what the oxygen you breathe in or the carbon dioxide you breathe out looks like under a microscope 1,000 times more powerful than any existing in the world today. Wait a minute. How can a chemist know what oxygen and carbon dioxide look like under a microscope that doesn't even exist? What happened to the scientific method? What happened to relying on observations and careful measurements? In fact, because chemists can't see the underlying structure of different materials, they have to rely on the scientific method even more. Chemists are a lot like detectives. Suppose a detective is trying to solve a murder case. What do they do? Obviously, the detective starts by visiting the site of the crime and looking for evidence. If the murderer has left enough clues behind, the detective can piece together a theory explaining what happened. Even though the detective wasn't at the crime scene when the crime was committed and didn't actually see the murderer kill the victim with the right evidence, the detective can be sure or the detective can be pretty sure of how the crime took place. It is the same with chemistry. When chemists go into the laboratory, they collect evidence by making measurements. Once chemists have collected enough clues from properties that they can observe, they use that evidence to piece together a theory explaining the properties that they cannot observe, the properties that are too small to see. What kind of properties do chemists actually measure in the laboratory? Well, you can probably guess a few. Imagine that you go to dinner at a friend's house and are served something you don't recognize. What type of observations might you make to determine exactly what you've been given? You might smell the food. You might note the color of the food. You might try to decide whether the food is a solid. You may try to decide whether the food is a liquid or a solid because if it you may try to decide whether the food is a liquid or a solid because if it's a liquid, it's probably soup or a drink. The temperature of the food could be useful if you wanted to know whether or not you had been served ice cream. You could also pick up a small amount of food with your fork and try to figure out how much it weighs. A light dessert might be something like an angel cake, while a heavy dessert is probably a pound cake. The quantity of food you have been given might be a clue also. Finally, you might want to know something about the food's texture. Is it hard and granular like sugar cubes, or soft and easy to spread like butter? Believe it or not, the observations you are likely to make when trying to identify an unknown food are very similar to the observations that a chemist makes when trying to learn about a new material. Chemists rely on smell, color, state, whether it is a solid or liquid or gas, temperature, volume, mass, which is related to weight, as will be discussed in a later section, and texture. There is, however, one property possibly used to learn about food, but that should definitely not be used to learn about chemical. There is, however, one property possibly used to learn about a food, but that should definitely not be used to learn about a chemical: taste. In the sections on the atomic theory, you will see exactly how measurements of certain properties help early chemists to develop theories about the chemical structure of matter on a scale much smaller than they could ever hope to see. You will also learn how these theories, in turn, allow us to make predictions about new materials that humankind has not yet created. The video below gives you some important tips on how to study chemistry in this class. With practice, you too can learn to think like a chemist, and you may even enjoy it. Video 1.5.1, How to Study Chemistry. After I read the contributions and attributions, I will give you the link and uh, expand on how to get this video from a screenshot using an Android device running Google Photos. Contributions and attributions for section 1.5. This page was constructed from content via the following contributors and edited topically or extensively by the LibreText development team to meet platform style, presentation, and quality. Marissa Alvear Agnew, Sacramento City College; Henry Agnew, University of California, Davis, or UC Davis, and also should be included. YouTube, though it is not necessarily listed here. This video is from YouTube. So if an Apple I, iPhone may also use this exact same process. I just don't have one here to observe it. But it is my theory that it works the same way. And I believe I remember having one, and it did. You're going to take a screenshot of this page. Then you're going to edit that screenshot in Google Photos and only hold, you're going to crop it so only the video screen is showing and the QR code, which is that square with other squares in it and data, in the upper left-hand corner. Once you don't have words or other text there, you then hit or press or depress lens, LENS, which on my phone is the third option, or it may pop up search inside screenshot, and from there you will get uh, a video that pops up as YouTube code, and you can follow it directly from there. So instead of just taking a whole screenshot of the page and expecting to find it from there, there's actually quite a lot of things to search Google Lens uh, or Google Goggles on sometimes, or Google Lens. So, and it can find many things for you. If you want just the video, you have to crop the photo to get it. These technology tools are how some students end up with a grade of A and others do not. Why should I have to go through that extra process to reuse this video, assuming you don't have the book in front of you, or if you do, but it's not, let's say it's in a PDF form, which itself isn't necessarily searchable, or I'm using Google Books or Playbooks to read the book, which you may be using something else. Well, these are methods you can use. This phone you have is a type of computer. It is, if you've ever seen or watched, if you've ever watched the film or movie, uh, 2001: A Space Odyssey. This is equivalent to a Tycho monolith, or what was called a monolith, a Tycho monolith. It was a large uh, stone made of a material that they didn't really know, a type of uh, glass, and on it were images that you could press. You touched it and you pressed it, and through a series of pressing an image and pressing an image and learning that I want that one again, I can go back to it. There were humans who were very hairy, and so they called them humanoids, meaning they weren't Homo sapien, and they were able to evolve at least to a more functional state by doing this and learn how to protect themselves. That was the idea of it. And then in a later book, I believe it was 2061, Odyssey 3, or 2016 Odyssey 2, by Arthur C. Clarke. These are science fiction books that approach fantasy, but we've been able to do a lot of it. You were able to take a lot of small, or apparently small, Tycho monoliths and suck away the gas around the planet Jupiter in some way. So it may be possible that these phones, those Tycho monoliths, could absorb gas, maybe as energy to power themselves, store it in a battery, and move it elsewhere, and then reveal it was the very core of Jupiter, if it were a planet on its own, was made out of either an agate or carbon, which made it a diamond, and was able to hold light and reflect it to produce something called another. Uh, another rival to the sun, which didn't produce chemical compositions. Or a sun is a type of star that produces elements, whereas this one was a crystal that worked like a light bulb and reflected outward, and so it was illuminated in that respect. And they called it Lucifer. And Lucifer literally means that which holds on to light and then can also express it. And so in the middle of Jupiter was this crystal, Lucifer. And Jupiter remained, but instead of having its gaseous form, and this gets into physics, it was only radio waves. The radio waves had vibrated some of the gas around itself to create visible clouds, and those visible clouds start moving in the same rotation as the radio waves. You just had the radio waves and no more gas. So all of that I know because I have been punching around on a phone since I had an iPhone 3, which was a type of taco monolith. Steve Jobs, who is of Syrian descent, at least on his father's side, and so Jobs is actually Job, and Job is Ayub, and so he is Steve Ayubi, and Ayubi is the family of the great Sultan Salahuddin or Saladin, who ruled Egypt and Syria, and also for a time Jerusalem. So these are very important people who've been involved in this and they care a lot. So that phone you have does a lot. And so you want to know how to do different things on it. And it's believed, at least, that you will evolve as you learn how to work the screen to do different things and control it. You'll evolve as a result of it. So that's how you get the information. Otherwise, you can direct your either search bar or your browser's address bar to https colon forward slash forward slash www.youtube.com forward slash WATCH question mark V equal sign V 1U capital F3 capital X capital B dash 9 underscore UC. Uh, Once again, that last part was incorrectly mentioned. I'm not going to mention the capital. I don't know that it matters. https colon forward slash forward slash www.youtube.com forward slash watch question mark V equals V1U F3XB dash 9UC. End of chapter, end of section 1.5, and except for the exercises, which I'll offer in a separate video, end of section 1.